Hello everyone. In this video, we are going to talk about threaded versus non-threaded scripts. So far, you have seen me every time I want to create a script and run it in CoppeliaSim, I use a non-threaded, right? So I always right click and go to add and then script and then go to simulation non-threaded, right? So here we can see that there is also a threaded one in both languages, Lua or Python. So what's the difference between these two? In the previous video, I told you the difference between a customization script and a simulation or a child script. Okay, this is for objects, this is for the scene. But we never really talked about threaded versus non-threaded. So this one here is made to explain that. And again, this is based on literally the scene that is made by the company CoppeliaSim themselves. So I did not really make this. I'm trying to explain it. The only thing I did was I went inside the code for the threaded script and I added a bunch of comments to it, and I'm gonna explain them so you understand it. And then to make it more educational, I'm gonna talk about the difference between threaded and non-threaded scripts and tell you about the differences. Okay, but first, to have an understanding, let's go ahead and run this code here so you get an idea. And all we are doing here, we have two blocks, two cubes. Each one of them has some kind of text attached to them, and these texts are simply in this case, these are the meshes that came with them. Okay, so they are not really something that you can print like you print over here or you print it inside the console. These guys are not something that is printed, they are added as a mesh. And since they are a child of the cube, they move with it. Okay, so when they start to move, you see the text starts moving with the block. Now, what is the code doing here? So for this one, there is a regular script that is non-threaded. And if you look at it, it has these four main parts that you know. There is an initialization, a cleanup, actuation, and sensing. In this case, there is no sensing. The initialization just gets the sim, this gets the handle for the cube, right? And then gets the position of the cube using get object position. Cleanup doesn't do anything. Again, it prints something, doesn't do anything. The actuation is the one that moves the objects. How? Pose number 2. So when you get the position of an object, it gives you all the three numbers, X, Y, and Z. Here, I'm only looking at pose number 2, which is the Y coordinate. And each time, I'm going to add to the Y coordinate a value of 1 over 1,000 or 1 mil. So the position of the box in the Y direction is increased by 1 mil each time, and that's how it is moving to the right because Y-axis is to the right. Now, similarly, if we look at the threaded code here, so let me use the same exact thing. So I use the exact same basically increment in the Y coordinate. And in this case, the structure is a little bit different. So we have some initialization, but when you create a threaded code, the main function is going to be something like this, syscall thread. Okay, and how do we use this thread? I'm going to talk about it. Most of it is comments, but the essence of the thing is exactly the same. Running, moving the box to the right side with the same increment. Now look what happens when I run them. Look what happens. Look. Before this one can even move, that one already got out of the scene. You see how fast the threaded one runs. Look again. See, it's like a rocket, just disappeared. This one is going like really a turtle, and that one was not going like a rabbit, it was going like a rocket. Look at that. You see? So even if I go ahead and in this threaded code, I make the increment 100 times smaller, right? So I'm bringing the speed of the block 100 times down. Let's see if it's something comparable. Look here. You see, still with 100 times slower, the threaded one is running much faster than the non-threaded one. So we want to know a little bit more about it. Clearly, you see that one is much faster than the other one. What is it? So here we're going to talk about this threaded one. So first, let me explain the major differences between them before we going back to the code. So what are the major differences? The non-threaded one is a synchronous code. Synchronous with what? With the simulation of the Coppelia. Per each step, each simulation step that Coppelia takes, the synchronous non-threaded script is executed only one time. The threaded one is asynchronous. It has no dependency on the simulation time, and it's what we call a coroutine. It runs on the side, okay? So who controls the timing of non-threaded? Of course, the scheduler of the CoppeliaSim that determines the step times, right? Or the size of the steps, the times. But here, the threaded can run as fast as it wants. Really, the frequency of that is as fast as the CPU is allowing it, while this one is controlled by the simulator. So let's say if the step size is 0.02, then you're 0.02, sorry, you're running 50 hertz. Or let's say if it's in one of my files, you saw that it was 0.005, so that is like a 200 hertz. But here, if the CPU clock is very fast, that's why the threaded can go a lot faster. So in terms of frequency and timing, that is the major difference and makes one of them much faster than the other. What else? So the next big thing is yield. Can you slow down or stop the code momentarily and then resume it? If you remember in one of my previous videos where I talked about simulation control, let me see if I can find it for you. In that video, I showed you that, yeah, there we go, here. So look, it was this code here. This one says simulation commands from the script. And you see here, if you look, one of the commands that you see on the right side of this says sim wait, right? So, and you remember, I could not run that sim wait. I could not run the sim stop or pause or anything. Why? Because the script that I tried to use sim wait in it, it was a non-threaded script, and I cannot use sim wait in a non-threaded script. But what about a threaded one? Can you use sim wait? Absolutely. It's the wait that controls the speed of the code, okay? And for that reason, if you talk about the determinism, I can say that a non-threaded code is fully deterministic. I can exactly know how many times it is going to run, let's say within 1 second. But here, absolutely not. It depends on how many waits I have put in it and for how long and where. So the behavior is quite a bit non-deterministic. Okay? In terms of running and concurrency, the non-threaded one has to go sequentially with other scripts. So first the scripts behind it would run, then this would run in series, sequential. But the non-threaded one can do cooperative multitasking. It's not a perfectly parallel thread, but it can run alongside with some other things, okay? It's a basically routine and cooperative multitasking. That's why it can help if you have a multi-core computer. Okay, so let's go down. Now, you might say, what about the performance? So, as I said, the performance of the non-threaded one is very predictable. In terms of the threaded one, it depends. Sometimes it can really stall the CPU if those yields are not done properly. So this one is very efficient and very nice and predictable. The non-threaded one, depending on how you do those yieldings or weights or something, you might mess up with the CPU. Okay. About debugging, the non-threaded one are very easy, but these guys, since they are not deterministic and it's a temporal logic and coroutine, they are a little bit harder to be debugged. Okay. Now, where would you use each one? The non-threaded one, you typically use them for scenarios that it's a real-time sensor or something. There is a fixed step size for the or sample time for that sensor. If you have a control algorithm, if you have places that you need low-level control loops, as I said, if you are reading from the sensors, real-time synchronizations, physics interactions, and so on. Anytime you need to be dealing with a fixed step size. That is where you use a non-threaded. On the other hand, where you have a movement and there are automation routines and there are stuff that can be done kind of parallel to each other or concurrently, that is in high-level tasks, the threading can be done as well. So let's say you have one basically vision sensor that needs to read some data, right, and process it, but it does not need to the data out of the computer vision or AI does not need to be used on a specific time interval. So it is processing on the side, and then your robot, your basically automation system, anything like that, is doing its job on the side. So can these two work along aside each other? Yes, they can. Okay, so this is the kind of thing that separates these two types of scripts. And if I go back, I wanted to explain a little bit about these threaded script. So if you see here, the initialization is exactly the same. You print something if you want, you get the sim. Now here is one extra thing that you need in the initialization. What is this? It says sim set stepping false. What is this? Here it is trying to disable the stepping mode. What is a stepping mode? In the stepping mode, if you run it in stepping mode, basically you need to manually trigger the simulation steps from an external client. Okay, so if your simulation needs to run when some external signal comes in, let's say you're using ROS or something connecting to some other computer controller or something, then you can put it in the stepping mode, right? But here, that's not what we want. We want this to run. We don't have any external control on this system. So we set it to false and say, hey, no stepping, keep running normally, like automatically, like any other code. Okay, that I have shown you so far. Now, this is the main code that runs as a coroutine. That is the main code syscall thread. First, you see it prints something, then it gets the handle of the cube, it gets the position of that, and during a while loop, it is updating the position. Now, what is this while loop doing? So this while loop continuously runs until the simulation is about to stop, and you can see that. While not, sim get simulation stopping. So when you stop the simulation, this guy becomes a 1. So not of that is 0, so this keeps running. You update the Y and then you apply it to the Y position of the cube. Okay? So you see that the threaded scripts, they should run until the simulation stops. This is how you stop it, by a while loop. Okay? Now, here, and then you can say that, hey, it finished. Now here, I did not use any sim wait, and that's why this one runs extremely fast when I use the same delta Y that I use for the non-threaded one. Even when I make it 100 times smaller, this is gonna go much faster. So now let's go back to this script. This time I want to make the delta Y the same as the other one, but I want to slow down this execution. So instead of it going like a rocket, remember here, Instead of this, I want to slow down this code by a wait. So here I'm gonna bring this line of code, and anytime I update the Y position, I say go ahead and wait for me maybe for, I don't know, something like 0.1 of a second or so. Okay, so I'm trying to slow it down. 0.1 of a second every time, not do anything, and then update the Y. So let's see if that slows it down. You see? It slowed it down to such extent that now the non-threaded one is going faster. Okay, so here I just commented out, so it shows the advantage of itself, right? Like that. And before I finish this video, I wanted to show you that you can use this command pause simulation. This command does work here, okay? So look, I added this here. I commented out that, as I showed you, that wait. So look what happens here. So when I run it, look, it goes to here, then reaches to that pause and it stops. So now it is waiting for me to click on this, and as soon as I do, boom, it goes away. Okay, so not only you can use the wait, you can also use the pause, you can use the start and the stop and everything. And this is the advantage of this threaded code. Okay, so hopefully this video was useful to you. I will provide the code for the threaded script on the video description. Remember that the non-threaded one doesn't have anything special. Okay, so hopefully this video was useful to you. I'll see you in the next video.